What if we could harness the power of a pulsar? Now, before you start planning your intergalactic power plant, let's break down what we're dealing with here. Pulsars are like the overachieving cousins of stars. They're neutron stars that spin faster than a politician's words during election season. These cosmic lighthouses blast out beams of radiation that would make any disco ball jealous. Imagine a star about 1.5 times the mass of our sun, but compressed into a sphere just 20 kilometers across. That's denser than a black hole's event horizon at a physics conference. These celestial spinners rotate at mind-boggling speeds, some making a complete turn in just milliseconds. It's like the universe's own fidget spinner, but with enough energy to power our entire civilization for millions of years. So what if we could tap into this cosmic battery? First things first, we need to find a suitable pulsar. Let's say we've spotted one that's relatively close, maybe just a few hundred light years away. No biggie, right? We'll just hop in our faster-than-light spaceship. Oh wait, we don't have those yet. Houston, we might have a problem. But let's assume we've cracked the whole interstellar travel thing. We arrive at our chosen pulsar, and it's time to set up our energy harvesting equipment. Now here's where things get a bit spicy. Pulsars are essentially nature's particle accelerators on steroids. They're constantly spewing out high-energy particles and radiation that would turn any astronaut into cosmic toast faster than you can say, "Beam me up, Scotty." So we'd need some seriously advanced shielding technology. We're talking force fields that would make the Starship Enterprise look like it's wrapped in tin foil. Assuming we've got our shields up and running, it's time to start collecting that sweet, sweet pulsar energy. But how do we do it? One idea is to use something called a Dyson sphere or swarm. No, not the vacuum cleaner, although cleaning up pulsar energy might require some heavy-duty suction. A Dyson sphere is a hypothetical megastructure that completely encompasses a star to capture its energy output. In our case, we'd be building it around a pulsar. Imagine millions of solar panels orbiting the pulsar, each one designed to withstand the intense radiation and gravitational forces. It's like building the ultimate cosmic solar farm, but instead of gentle sunlight, we're dealing with beams that could slice through planets like a hot knife through butter. As the pulsar spins, our Dyson swarm would capture the energy from its beams, converting it into usable power. We're talking about an energy yield that would make our current power plants look like AA batteries in comparison. With this kind of power at our fingertips, the possibilities are almost endless. We could solve Earth's energy crisis overnight. Say goodbye to fossil fuels and hello to pulsar-powered everything. Want to terraform Mars? No problem. We've got enough energy to melt those polar ice caps and create an atmosphere faster than you can say, total recall. Feeling a bit chilly? Let's move the entire Earth a smidge closer to the sun. With pulsar power, it's just a matter of firing up our planetary engines. Interstellar travel? Now we're talking. With the energy from a pulsar, we could potentially accelerate spacecraft to relativistic speeds. Weekend trips to Alpha Centauri could become the new norm. Sorry, boss, can't come to work on Monday. I'm stuck in a time dilation field near a black hole. But let's not get ahead of ourselves. Harnessing a pulsar's power comes with its fair share of challenges. For one, the immense gravitational forces around a pulsar would make construction a nightmare. It's like trying to build a house of cards in a hurricane while riding a mechanical bull. Then there's the issue of energy transmission. How do we get all that power back to Earth? We could use some sort of cosmic power cable, but at hundreds of light years long, it might be a bit tricky to manage. Honey, have you seen the extension cord? I think I left it somewhere between here and the Crab Nebula. Beaming the energy back using advanced lasers or microwaves could work, but one slight misalignment and we might accidentally fry a continent or two. Oops! And let's not forget about the potential for catastrophic failure. If something goes wrong with our pulsar power plant, we're not just talking about a local blackout. We're looking at an explosion that could outshine entire galaxies. Talk about a bright idea gone wrong. But hey, no pain, no gain, right? If we could overcome these challenges, the rewards would be astronomical. Pun absolutely intended. We'd have enough energy to power civilizations for billions of years. We could explore the cosmos, reshape planets, and maybe even create our own mini-pulsars for portable power. Pulsar in a pocket, never run out of phone battery again. The ability to harness a pulsar's power would fundamentally change our place in the universe. We'd go from a Type 1 civilization on the Kardashev scale to a solid Type 2, maybe even pushing Type 3. We'd be cosmic engineers shaping the very fabric of space-time to our will. Of course, with great power comes great responsibility. We'd need to be careful not to let our newfound energy go to our heads. The last thing we want is to become the galaxy's energy hogs, leaving other emerging civilizations in the dark. Cosmic etiquette is important, folks. So what have we learned from this little thought experiment? Well, harnessing the power of a pulsar is theoretically possible, but practically, let's just say it's a bit of a challenge. It's like trying to catch lightning in a bottle, if the lightning was a continuous beam of death rays and the bottle was the size of a solar system. But hey, that's what makes it fun to think about. Who knows? Maybe in a few thousand years our descendants will look back on this video and laugh at how quaint our ideas were. Can you believe they thought harnessing a pulsar was hard? We do it for our school science projects now. Until then, we'll keep dreaming big and reaching for the stars, or in this case, the pulsars. Who knows what incredible discoveries await us in the cosmos? So the next time you're gazing up at the night sky, remember that each of those twinkling points of light could be a potential cosmic power plant just waiting for us to figure out how to plug in. And who knows, maybe one day we'll be able to say, one small step for man, one giant leap for our electric bill. Until then, keep looking up, stay curious, and remember, in space, no one you generate clean, unlimited energy. This is Cosmic Power Rangers signing off. May the force of pulsars be with you.